Container deployment is an important strategy in Azure AI solutions, enabling effective scaling, portability, and rapid deployment. Containers encapsulate applications along with their dependencies and environment, ensuring consistency across different deployment environments. Utilizing container-based architectures allows applications, including AI workloads, to run reliably regardless of the underlying infrastructure, promoting efficient resource usage, scalability, and quick continuous integration and deployment processes. Azure provides comprehensive services for container management, including Azure Container Instances, Azure Kubernetes Service, AKS, and Azure Container Registry, simplifying the deployment and orchestration of containerized AI applications. Deploying AI services within containers offers numerous benefits: portability, consistent behavior across different environments, development, testing, production. Scalability, easy horizontal scaling to meet workload demands. Rapid deployment. Containers enable fast deployment, accelerating operational workflows. Isolation. Containers isolate applications, facilitating security improvements. Resource efficiency. Effective resource usage through minimal overhead. Continuous integration/continuous deployment. Supports agile development practices by enabling quick and repeatable application updates and rollbacks in Azure-based AI solutions. These advantages substantially optimize operational efficiency and application performance. Effective planning ensures the successful deployment of containerized AI applications. Key planning considerations include resource needs, estimating CPU, RAM, GPU, and storage requirements. Scalability strategy, ensuring easy horizontal scaling via cluster auto-scaling and load balancing. Networking, effective handling of network configuration and security aspects. Persistence, determining the necessity and management of data persistence and storage. Monitoring and logging, planning comprehensive monitoring, alerting setups, and log storage. Service selection, choosing appropriate Azure services, AKS, ACI, based on application complexity and management needs. Comprehensive planning aligns deployments with operational and technical requirements. Azure Container Registry, ACR, securely stores container images, allowing efficient and secure management. Key features include image storage and retrieval, secure storage and efficient distribution of container images. Security, image vulnerability scanning and proactive security improvements. Access control, Azure Active Directory integration for granular access permissions. Integration, seamless integration with CI/CD pipelines, automatically building and deploying images when code changes. Replication, geo-distributed registries for primary and backup replication. Scalability, high-throughput deployment for large-scale AI workloads. Leveraging ACR provides a robust foundation for container deployments. Azure Container Instances, ACI, offers simple, fast deployments without complex orchestration. Key aspects include ease, quick setup for single containers and straightforward scenarios. Agility, rapid startups, suitable for on-demand and transient AI workloads. Billing, per second billing optimizes costs for intermittent workloads. Simple automation, integration via Azure CLI, Azure SDKs, or Azure Portal. Scalability, limited auto-scaling, typically suitable for smaller scale deployments. ACI is effective for prototypes, development/testing environments, and workloads requiring minimal maintenance overhead combined with rapid deployment capabilities. Azure Kubernetes Service, AKS, provides powerful container orchestration, suitable for complex and large-scale deployments. Benefits include advanced orchestration and scaling, automated load balancing, cluster auto-scaling, rolling updates and rollbacks. High availability, robust deployment ensuring application uptime. Security, enhanced security with RBAC integration and Azure AD synchronization. Flexibility, customizable control over infrastructure and deployment configurations. Monitoring, extensive integration with Azure Monitor for in-depth analysis and reporting. AKS is optimal for managing and scaling production-grade AI applications requiring sophisticated orchestration functionality. Deploying AI containers to AKS generally involves these steps: containerization, Dockerizing the AI application, and creating an image. Image storage, uploading the container to Azure Container Registry securely. Cluster creation, creating an AKS cluster defining node counts, VM sizes, and network configurations. Cluster configuration, setting up namespaces, resource quotas, and service accounts. Deployment, using Kubernetes manifest files, YAML, to deploy containers to AKS. Scaling and management, configuring auto-scaling strategies, monitoring, logging, and orchestrating rolling updates and patches. Each step requires careful configuration to ensure optimal service performance and resource allocation. Securing container deployments is critical. Consider these key areas: role-based access control. RBAC assigning correct permissions through Azure RBAC ensures appropriate resource accessibility. Image vulnerability scanning. Regular scans prevent using compromised containers. Secure communication. Implementing secure protocols, TLS/SSL, and secure networking configurations. Runtime protection. Monitoring container behavior continually for anomalies. Secrets management. Securely storing sensitive credentials and keys via Azure Key Vault. Regular updates. Ensuring containers and underlying platforms are updated regularly to avoid security vulnerabilities. Consistent monitoring and logging facilitate reliable operations. Azure offers integrated tools like Azure Monitor, Log Analytics, aggregating container logs for alerts and analytics using Azure Log Analytics. Metrics collection, tracking resource usage metrics like CPU, RAM, network activity. Health checks, implementing readiness and liveness probes monitor container health continuously. Alerting, promptly notifying support teams of potential issues through automated alerts. Performance visualization, dashboard customization via Azure Monitor to visualize key metrics and logs effectively. Efficient monitoring and logging help proactively manage and optimize deployments. Implementing continuous integration and continuous delivery, CI/CD, enhances agility, reliability, and efficiency. Automated builds, frequent automated container builds triggered by code commits. Continuous testing. Automation ensures applications meet performance and security requirements. Deployment automation. Automatic container deployment to test, stage, production environments. Rollback handling. Quick rollback deployments if issues arise during an update. Integration tools. Azure DevOps, GitHub Actions effectively integrate with container registries and Azure Kubernetes. Including CI/CD practices significantly shortens deployment cycle times and improves software quality in container-based deployments. Adopting best practices ensures efficient container deployment. Use lightweight images. Minimizing container sizes reduces startup times and storage usage. Tagging strategies. Clear tagging simplifies image management and rollbacks. Define resource limits. Clearly stipulated resource limits and requests enhance stability. Regular vulnerability updates. Frequent image and software updates prevent security vulnerabilities. Persistent data storage. Use persistent volumes effectively for data stability. Proper documentation. Thorough documentation simplifies management and ensures consistency. Following these best practices proactively enhances container performance, reliability, and manageability. Common container deployment issues include application errors, performance bottlenecks, and scaling issues. Effective troubleshooting tactics involve monitoring log files to diagnose crashes or abnormal behaviors, utilizing Azure monitoring tools for detailed performance metrics, analyzing container resource consumption, performing health checks and validation tests systematically, using Azure support resources and documentation for guidance, implementing efficient rollback strategies for rapid recovery. Proactive troubleshooting ensures reduced application downtime and improved productivity in managing AI workloads.